Let's have an example on how to find the cross product of two vectors. We have here vector u and vector v. Remember, this can be written as u is equal to 2i plus j minus 3k. Vector v can be written as 3i minus j plus 4k. So for the cross product, u cross v, the first vector should be at the top. This would be 2i plus j minus 3k, and vector v at the bottom, that would be 3i minus j plus 4k. So 2i times 3i is 6 times I cross I. From the properties of your vectors, you just multiply the scalars and separately multiply the vectors I and I. 2i times negative j is negative 2 I times j, I cross j. This would be 2i times 4k is positive 8 I cross k. Then we have here j times 3i. This is 3 times j cross I, negative j cross j plus 4 j cross k, negative 9 k cross I, positive 3 k cross j, negative 12 k cross k. Now remember that if you multiply or cross product a vector from itself, that would just be equal to 0. So we have here I cross I is 0, j cross I is 0, and k cross k is equal to 0. 0 times the scalar here is equal to a 0 vector. Now, for the other terms, we will use this circle to find the cross product of each vectors. So this would be equal to, that is negative 2 I cross j. So it follows the arrow here, I cross j, so that would be positive k, plus 8 I cross k does not follow the direction of the arrow, so that would be negative j, plus 3 j cross I. It does not follow the direction of the arrow, so that would be negative k. And we have here 4 j cross k is following the direction of the arrow, that would be positive I. Next, negative 9 k cross I also follows the direction of the arrow, so that would be j, plus 3 k cross j does not follow the direction, so that would be negative I. Simplifying, we will have negative 2k, negative 8j, negative 3k, plus 4i, minus 9j, minus 3i. So simplifying further, we have here u cross v is equal to, combining like terms, 4i minus 3i is simply I. We also have, for j, negative 8j minus 9j is negative 17j. For k, that would be negative 5k. This can also be written as 1, negative 17, and negative 5. Remember that the answer for a cross product should always be a vector contrasting the dot product, which is having an answer of a scalar quantity. For the cross product, we have a property that U cross V is equal to the negative of V cross U. Let's try to check whether this property is correct by solving for the value of V cross U. We have already solved for U cross V given as I negative 17, negative 5. So for this one, V is the first vector. Let's copy it first. 3I minus J plus 4K. And we have 2I plus J minus 3K. So for this cross product, we will have 6I cross I plus 3I cross J negative 9I cross K. Next, negative 2 J cross I negative 1 J cross J and positive 3 J cross K. Next, we have positive 8 K cross I plus 4 K cross J negative 12 K cross K. Similarly, if you cross product a vector by itself, that would be equal to 0. So we have reduced the terms. Next, we will use this circular guide for the signs of our vector products. This would be equal to I cross J follows a direction, so that would be positive K. Next, negative 9 I cross K reverse, so that would be negative J. Then negative 2 J cross I, so it does not follow the direction of the arrows, that would be negative K. And we have positive 3 J cross K, so positive I, plus 8 K cross I, that is positive J. And lastly, plus 4 K cross J, that is negative I. So, combining the terms, we have U cross V or V cross U is equal to 3 minus 4 is negative I. For J, that would be positive 9 plus 8, that would be positive 17 J. For K, that would be 3 plus 2K, or that would be equal to positive 5K. So V cross U is equal to negative 1, positive 17, and positive 5. If you will observe here, we have satisfied our property. U cross V is positive 1, negative 17, and negative 5. And if you multiply V cross U by a scalar quantity negative 1, that would yield to U cross V. So we have satisfied the property of the cross products.